Okay, so how do we evaluate the effectiveness of a normality test? Well, in general, we use what's called the power. And so the power is a measure of the test's ability to correctly reject the null hypothesis. So that means if you've ever heard of type 2 error, which is type 2 error is failing to reject the null hypothesis when the null hypothesis is not true. So in this case, when non-normal data is fed to the test, its power is the ability to detect that non-normality and reject the data. So how we actually evaluate the power, we use what's called Monte Carlo simulation to create population data from non-normal distributions. And then we pull random samples from these populations and we run them through each test. And so like in a study that we're going to be talking about a lot, there was 4,000 samples generated on multiple different distributions using the inverse cumulative distribution functions from random data. And then it was pulled at different sample sizes, 10, 20, 25, 30, 50, 100, 200, 500, 1,000, 2,000 to give kind of an overarching view of what happens at different sample sizes. And at each sample size, you do thousands of tests, whether that's 10,000 different samples of that sample size. And then we figure out, okay, so we know we fed non-normal data. How many of those times at that sample size did the test correctly reject the null hypothesis? And then we divide it by the total number of trials. And that gives us a percentage, and that percentage is the power, okay?